Okay, today we're going to talk about why some of the trig identity derivatives are what they are. Um, so just a reminder of what they are. The derivative, remember this d dx means derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine x. The derivative of tangent x equals secant squared x. The derivative of cotangent, oops, unequals there, is negative cosecant squared. And the derivative of secant x is secant x tangent x. And the derivative of cosecant x is negative cosecant x cotangent x. So the first one I'm going to prove is sine, and to do that, we're going to use the sum. Well, we're going to use the limit definition here. So limit as h approaches 0 of sine of x plus h. Remember, this limit definition is f of x plus h minus f of x. So limit as h approaches 0 of this. This is my definition of a derivative. And so I'm going to use that here. The next thing I'm going to use is my sum identity, which this is a trig identity. And I'm not going to write, I don't usually write the limit in each step. Sine x cosine h plus cosine h sine h, no, cosine x sine h, minus sine x over h. I'm going to gather the terms with the sine x together. And then from these first two, I'm going to factor out a sine x. So I'm just marking them there. Okay. So now I can start splitting things up. There are a few known limits that I'm about to use, but these ones are known. We haven't necessarily gone over them yet, but I'm going to write them up here. Limit as h approaches 0. You could graph this and check it on your calculator. Graph and sine x over x. You have to use x on a calculator, but and We haven't spent a ton of time on limits, so we have not used these yet. Oop, wait, I got these backwards. Sine h over h is 1. If you care to graph that on a calculator, you can. So what I'm going to do now is I'm going to divide this thing up into a whole bunch of different things. So my two terms, I'm going to split it up. I have to put an h with each one of my two terms with a plus. So there's an h there, there's an h here. So it means I need to have the h go to one of them. So I'm going to do limit of sine x. These are all as h approaches 0 times limit. And I can do this with limits. I can take all the limits separately of things that I'm multiplying or adding. Okay, so the last one. So I've got limit as h approaches 0. Limit as h approaches 0 of sine x, actually don't need to have that written out, is just sine x. There's no h in it. Now I'm going to use either known limits or plugging in. Oh, I missed an x here. So I've got sine x. Limit as h approaches 0 of cosine h minus 1 over h is 0. Limit as h approaches 0 of cosine x is just cosine x. Again, there's no h. And limit of h approaches 0 of sine h over h, that's this first known limit, is 1. So I've got 0 times sine x is 0 plus cosine x times 1 is cosine x. The proofs of those limits is another thing. Pretty easy to tell if you just graph them and look at what they're close to. They both have division by 0, so they both have holes when you get there, but you can see from the graphs. And this is in 3.5. They have the graphs shown right above it. Derivative of cosine, very similar. Okay. Using the cosine sum identity and then working to these known limits. Okay. So that is the sine. Okay. Let's do I'm going to derive the tangent. And I'm going to use the power rule. Actually, I'm going to use the power and the quotient rule here. So I'm not going to use this limit definition because now I've established that the derivative of sine is cosine. And we're going to, a similar derivation gives me cosine as negative sine. So if you're remembering those rules. Okay, so here we go with tangent. Come on, pen. Okay, there we go. So the derivative of tangent I know is secant squared. So functionally here, I'm doing the derivative of the sine over the cosine. And this is a quotient rule. And my quotient rule is bottom times top, derivative of top. Yeah. The quotient rule, u over v equals, this is a little bit of shortcut notation, u prime plus u v prime over v squared. So bottom is cosine times derivative of top. Derivative of top is cosine squared x. No, not cosine squared, just cosine x. Derivative of top is derivative of sine. Plus u is sine. It's not plus, it's minus. I have my quotient rule wrong. That's a minus. I know how this is supposed to work out, so when I make a mistake. Okay, so now I've got a minus there. And derivative of bottom is, derivative of cosine is negative sine over cosine squared. That is, so my numerator is cosine times cosine is cosine squared x, minus sine x times negative sine is plus sine squared x over cosine squared x. My numerator is one of my most basic trig identities. Cosine squared x plus sine squared x equals 1. And 1 over cosine squared is secant squared. Let's derive the secant, and I will leave the other ones for homework problems, because it does ask you to do some of these. It might ask you to do one of these too. 1 over cosine of x. Again, I have to use a quotient rule. ODI minus ID low. So derivative of 1 is 0. Derivative of cosine x is negative sine x. Over the cosine of x. This could also be done with the chain rule if you'd like. Or cosine squared x. I'll show that in a second too. 0 times cosine x is 0. Negative 1 times negative sine x is sine x. And this is sine x over cosine x times 1 over cosine x, which is equal to tangent x secant x. And usually we write it in this order. But you can switch the order on multiplication. This is not matrices. Okay, now let's do it with this quotient rule. So secant x would be same as taking the derivative of the cosine x to the negative first power. Notice I did not write the -1 next to the cosine. That would be inverse cosine. So to take the derivative, bring the -1 in front. To the -2, subtract 1 from the power, multiplied by the derivative of the inside. The cosine x to the -2 can go to the numerator as cosine squared x. -1 times negative sine x is positive sine x. These two are the same. The rest of the work is already shown. So that is a few basic proofs of trig identities.